Hi everyone, my name is Marzieh Zargari. I'm a machine learning slash deep learning engineer who has worked mostly in industry. I have mostly worked in natural language processing applications like chatbots and search engines and retrieval pipelines and retrieval applications. And I have heard so many times from Neuromatch Academy. So many of my coworkers have attended Neuromatch as teaching assistants, and they all love the experience. And I wanted to, see, give it a shot and see what happens. And I'm pretty sure I'm going to love the experience just as much as them. So now, without any hesitation, let's just go through. Uh, you know, Continuing from our previous exercise and what we already talked about, you guys know about the differential equations and the gradient descent algorithm. Now you see that there are so many layers during our neural networks and so many manipulations our data is going to go through. And so, using the chain rule, calculating the gradients can make it a little bit, complicated. So how can PyTorch actually helps us, makes it a little bit more automatic and faster, so we don't have to actually think about any of these things. So now PyTorch use something called autograd, which is going to automatically calculate the gradients. It happens when we do a forward pass, and in here we can see it happens when we do a forward pass. Every time we move the input through our model, it creates a graph, which is just not just the variable itself, but also how it's created. So when we do the back propagation, we already know the respected function that has created a certain variable. So now we can calculate the gradients. It happens automatically every time we do a forward pass. And then when we do the back propagation and backward pass, it stores the gradients and for each node and each variable, since we know how it's already calculated. So now let's go through our exercise, which you guys have already finished. Now we're going to go through, so there's no, complications or anything vague in here. So we have already created this class. We have just one weight and one bias. Looking at our schema, we just have this one. This is our neural network, or this is our just computational graph. And we're just going to work through our exercise to forward pass. I'm just going to comment this part. Looking at our schema, we have just one weight, which is going to be multiplied by our x, our inputs, our scalar inputs, and it's going to be added. Our bias is going to be added into it, and then we're going to have our activation function, which is we're going to use the PyTorch tanh method. Okay, and now we have our prediction. We're just going to move through our loss. We already talked about mean squared loss, so it just is going to be just really the same thing. We have two scalars. We're going to use mean squared loss, which is going to be our y true, which is our label, what we should predict, and minus what we have actually predicted. And here, and we're going to, I think I used underline instead of minus. And then we're going to square it. And this is going to be our loss. Then we're going to move to the next section, which we're going to call our actually class and see how it works. We have our, let's see if we can get it. Loss function, square loss. I guess I have to comment this section. Just going to comment that, and I'm going to run it again and see here it is, our initial weight, our initial bias. We have input scalar in the amount of number one. It's going to be multiplied by minus half and then added to minus half, which is going to create the prediction of 0. But what we should have predicted was going to be 7, and the loss is going to be 49. So that's it. See you guys.